Delighted to have you all here for our Life Science and Healthcare Science Virtual Student Conference. So I'm Tracy, and my role is a Provider Development Officer. So what does that mean? So what it means is I support your teachers in the delivery of your qualifications. So like our T-level healthcare science or T-level science qualification, I'm here to support them to understand the qualification so they can really make it really brilliant and share that with you as students and find lots of different interesting ways, well, I think I help here, different interesting ways to support activities around your qualification as well. So what are we doing today and what are we exploring? So right into its basic form. So whether you're currently pursuing a technical qualification, which based on some of the teachers that I already know in here, I know you are already undergoing the T-levels, there are lots of different vocational pathways that are going to link to what we're going to explore today and the areas that we're going to explore today. And it's not exhaustive. It can come from healthcare science, it come from science, even technically the engineering or digital technologies, wherever you're starting now. It's really exciting that the roles you're going to hear about don't all have to necessarily start at the same place. And you're going to hear about our speakers' journeys today. We're going to take a deep dive into all those different career paths, and we're going to look at sort of real world experiences and sort of those essential skills that you're going to need to develop. Doesn't need to be qualification knowledge specific, you don't need to know everything about pathology before you go and undergo a qualification or begin a journey in pathology. It's those skills that are adaptable and that transfer across many qualifications that you're probably already developing. So this is our first one. So I said this is your first poll that I'm going to ask you to do. Okay, so onto your Slido. So scan the QR code, or in the Q&A at the top, I've popped the link, or just put on your phone or in your browser slido.com and put in hashtag healthcare science, all capitals is your code. So a bit like Kahoot, if you've done Kahoot before. Okay, there's a place to put your code. And we're going to start our poll. So which area of healthcare science interests you the most? Here we go. So we've got biomedical, pathology, medicine, medical physics and radiology, clinical engineering, physiological sciences, and there's also one at the bottom. I'm not sure yet if you're not 100% sure of what you want to follow. Wonderful. That's brilliant. Just give everybody a few more seconds to vote. Look at you all with this tech. I did this recently at a teacher's CPD event face-to-face, and it broke them a little. My students out there, it was like, what is this? Using technology on their phone, it really confused them. And I used Padlet as well, and they couldn't get the little boxes to shrink. You're all amazing at this, so you're doing a good job. So what we're looking at predominantly here is biomedical science. It'll be interesting to what your understanding of what biomedical science is as well, and what you learned today with those from our speakers who have followed the biomedical science journey, but actually, what do they do? What is their role? We're looking at pathology as well, and then the next one we have is I'm not sure yet, and that is okay. And hopefully today might help sort of inspire you and focus the key areas that you would like to maybe go to next in your journey. Don't worry, keep your Slido open on your device. We will come back to this and have more activities on there. So why is healthcare science crucial in modern medicine? So healthcare science is at the heart of sort of diagnosing, treating and preventing disease. It plays a critical role in keeping people healthy and ensuring patients receive the best care possible. So across the NHS and healthcare systems worldwide, there's over 50 specialisms in healthcare science. You might not have been aware, but they're actually over 50. And that number, I think, continues to grow as we realise there's more areas that we need to focus on and specialise in. These range from those life sciences, physiological sciences, clinical bioinformatics, and it's all sort of a blend now of technology, science and patient care. And it's really ensuring that healthcare continues to advance as well through innovation and research. So from laboratory diagnostics to cutting edge medical devices, they really drive the future of medicine. Um, so if you're really passionate about science and making a difference, there are countless opportunities for you. So I will follow up with these slides after, and you'll be able to click on this NHS link and you'll be able to look at some of those roles, some of those 50 specialisms on the NHS website. So back to Slido, and we're going to do a word cloud. So, well, words cloud. You can put more than one words in your little box. Sometimes we have it where people just put one word a box and keep clicking it. You can put more than one word. You can put a sentence in your box. What skills do you think are important for a career in healthcare science? Communication, nice. Oh, look at that one going big. Communication's a popular one. Teamwork, hospitality. So are we thinking hospitality in relation to hotels, or are we thinking like hospitals? Yeah, so hospitality is usually like hotels and that sort of side of it, and restaurants. Confidence. Oh, courage. I love that word. Empathy, definitely. Teamwork. Yes, these are all really important skills. Problem solving, absolutely. Open mind. Oh, nice. Following processes. These are really great. Yes, we had scientific knowledge in there, but I'm glad that's not the most biggest one. It's not all about having knowledge. It is really about all these other skills that you can develop. Wonderful, guys. Really, really nice. Yeah. Clearly communication, time management, teamwork, empathy, and courage. These are becoming our big words there. And I love all of those words. They are fantastic. Well done. Um, Excellent. So we're going to move on. Please feel free to finish your last sentence there, but these are fantastic. Well done. So exploring these diverse roles in healthcare science. So it's really broad and dynamic, as we mentioned earlier. So we've got the pathology and laboratory medicine. So these that are unsure, maybe it's because you're not quite sure what these specific areas, when you voted unsure earlier, what do they actually mean and what do they incorporate? So scientists in this sort of field, and this is very broad, okay, very broad statements that I'm making. So in pathology and lab science, scientists in this field analyze sort of samples to detect and diagnose diseases and really playing that crucial role in patient treatment. We have biomedical science, so these professionals research medical conditions, develop diagnostic tests, helping to advance medicine. Clinical engineers design, develop, maintain medical equipment, ensuring hospitals have the latest technology to care for patients. Physiological science is the area that monitors and treats patients using specialist techniques such as cardiology, audiology to assess sort of bodily functions. Clinical bioinformatics, this is really growing field of sort of data science and AI in healthcare, and it's sort of revolutioning how patient information is analysed to improve treatment or outcomes. Radiation and medical physics. So these professions manage radiotherapy, MRI, and other radiation-based treatments. And they can help sort of diagnose and treat conditions like cancer. So what do you need to start this journey? Well, there's lots of different ways you can start this, but this can be really depends on how you learn or what path that you want to take. Um, we have all those fantastic transferable skills that you already picked out there. That big one, communication, empathy. Um, but you can go through T levels, apprenticeships, A levels, degrees, foundation degrees. There are many routes into these careers, and this might change throughout your life about which of these options that you will pick. You're now considering what you're going to do now and what you might pick now to get you there, but that could change in the future. So how do they transform lives, our healthcare scientists? So just a quick snapshot. So clinical engineering, so during the COVID pandemic, they were really crucial in designing new ventilators to treat critical patients. Our biomedical scientists, they've identified rare blood disorders in routine tests, leading to early life-saving treatments. In pathology and cancer diagnosis, they really help support diagnosing rare cancers as well and looking at targeted therapy around that to increase survival rates. Um, Healthcare scientists impact lives daily. So, on to our esteemed speakers now. So, we are going to begin with Dr. Maria Benedicta Edwards. She is the Deputy Head of Clinical Engineering at Royal Berkshire Hospital. She is a specialist in designing and so specialist in the area of designing and maintaining life-saving medical equipment, where then we'll follow by with Maeve and Jacqueline. And Maeve is from the Pathology Network, an educational trainer, very much around that sort of cellular pathology, biomedical science, and she'll tell you more about what that all means. If you're not sure what all that jargon means, that's absolutely fine. She's going to break that down for you. And again, Jackie also comes is a biomedical scientist, but her focus is has been recently mainly around sort of hematology as well. Um, so let's begin. I'm going to pass you over to Dr. Maria Benedicta. Thank you.
Good morning, everyone. Well, I'm hoping my presentation goes according to plan. I have to say that it's going to be weird having somebody else do the slides. But anyway, here goes. So yeah, I'm Maria Benedicta Edwards and I work as Deputy Head of Clinical Engineering at the Royal Berkshire Hospital in Reading in Berkshire. Can I have the next slide, please? And before I start, I just wanted to give you a sort of a brief overview of what to expect from my presentation today. So a short biography, and I hope I don't rabble on too much about it. And then something of a bit of a memory game, because I'm going to be talking about SOPs and why they're important. So to sort of help you do that, it's a bit of a memory game that will then help hopefully lead you on to a little quiz of 8 questions that we've got, just to test your knowledge. It's a fun thing. So, it's not sort of an exam or anything like that. It's just a bit of fun, to see whether or not actually I've told you what you need to know, and whether or not I've done it properly or whether I failed abysmally. And then we'll have a quick summary of, what we've gone through today, and then hopefully there'll be time for questions and answers. Okay, so next slide, please. So I hate this bit where I've got to tell you about myself. I think I get really embarrassed. As Tracy said, there are all sorts of different routes to being a healthcare scientist. And certainly when I started off as a sort of 18, thinking about university, and I wanted to be a clinical psychologist, I was really interested in people and their problems and how to sort of, help them and support them. So I did a degree at Liverpool University in psychology. But towards the end of that, I decided that whilst I was still interested in and people and supporting them, that probably wasn't really the field for me. There was an awful lot of sitting around, and I like to be a bit more active. But what it did give me was an introduction to research skills. And methods. And so I liked that because I'm quite, I suppose, systematic. And so I like lots of process. I like step by step to learn things. And with research, there are all sorts of different research avenues and different topics, I suppose you'd call in research. And I really like that sort of investigation. And so that's what my psychology degree, that first degree, sort of helped me with, and as I say, introduced me to that sort of investigation side of things. So after that, very interested in health. So I went off to the London School of Economics, and did a couple of degrees there, in health economics. And again, that was all about looking at health and the provision of healthcare, and how we fund that. But again, because of the nature of the sort of the courses, there was an awful lot of research involved in that. So it sort of broadened my sort of scope and interest in developing research around healthcare and how we provide it and how we fund it and what the problems are. And, we've all heard about funding in the NHS, so, and how we can save money. So it was all built around that. But as I say, I think when you um, study is a form of research, really, because of course you've got to go away and you've got to do some study on your own. So you've got to find information out, and how do you do that? And where do you look? How do you find? How do you know what's the important thing, and sort of pull out all the important things? So whilst it was sort of slightly different doing masters in health economics, it was still very much around research and around health and exploring more about where we could go with that. um, and as I say, it's about that sort of process that we talk about, and process is procedure, so how we do things, the time and time again, so that we get results that we can rely on, that we know are accurate. Um, and after LSE, I actually went into work, but obviously trying to put together a presentation, you put all your exams together and then you put your work skills. So I've got my sort of PhD, so my doctorate on this slide at University of Strathclyde in Glasgow. Um, but between my master's at London and Strathclyde, there was about 20 years where I actually went to work. So, which during my working sort of career is what got me interested in wanting to do a PhD in bioengineering at Strathclyde. So I might mention that a bit later if I remember. But if we can go on to the next slide. So my first job after university was at the Hammersmith Hospital in London, so right next door to Wormwood Scrubs Prison, which was interesting. Um, and there I worked in the cardiac surgery department, and I headed up a little research unit. And we collected information on patients, every single patient in the UK who had heart valve replacement surgery. So I don't know if you're familiar as sort of biomedical science students, as sort of the anatomy of the heart, but the heart has four valves that allow blood to sort of, pump through to the different chambers, and then close to stop it sort of going back into the chamber, flowing the wrong way. And sometimes those become diseased and they don't work properly, and so they have to be changed, and you get an artificial heart, whether it's what we call a mechanical valve, so something that's made from tungsten, from pyrolytic carbon. They used to be stainless steel. Now we're looking at something called tissue valves. So you use tissues from pigs. You can use bovine, so from cows. Um, I don't really think they do equine now, but there's an awful lot now in tissue regeneration. So looking at sort of how we can create false tissue and then mold it into an artificial heart valve. Um, Oh, sorry, that's Tracy popping up with the thing in the chat box. So that's where I worked. And so in the UK, there were 52 cardiac surgeon centres around the UK that did heart valve replacement surgery. So we collected all that information about the patient, about the surgery, about why they had the surgery, and we followed them through so that we could see whether or not they had any complications after they had the heart valves, and whether or not, if and when they died, whether or not their death could be attributed or was caused by that artificial heart valve. Um, so as you can imagine, 52 centres around the UK, and we had one centre collecting all this information, meant that we had to have very strict processes in place, so methods of collecting that data. And so a process really is a bit like a recipe. It's a step-by-step procedure on how to do something. And if you cook, if you bake and you follow a recipe, for baking a cake, then actually that's a process. And so you might call it sort of standard operating procedure, which is really how you do something. So how you do it, what you need to do it, and then what the end result is. So it's that step-by-step method of doing something. So at the Hammersmith, we had to have the same process so that everybody sent in the same type of data in the same way so that we could record it in the same way, which then meant that actually when we came to analyze the data, we knew that the quality of the data and the accuracy were all correct. And so we could rely on the information that we produced. And it also, it cut down on time because everybody's sending the same sort of data in the same format. So we're not having to spend a lot of time sort of trying to decipher, did they mean this? Are they talking about that? So it was very process driven. So process and procedures are two terms that are often used in the same way, and slightly different, but essentially they mean the same. So that's what I did for about 10 years and then was made redundant, and went to work at St. George's on something called the asymptomatic carotid surgery artery trial. And that was setting up another health study for patients who had narrowing of the carotid artery, which meant that blood wouldn't flow as it should do to the brain, so then it could cause all sorts of problems, something called vascular dementia, as well as other problems. And so that was a European study, so lots of different centres around Europe, all contributing their information into this place in London. So again, it was the same sort of thing that we had to have, procedures in place so that people sent in the information that we wanted in the same format so that when we came to analyze the data, then we could sort of do that easily and we were confident that the information was accurate and reliable. So throughout sort of my sort of career, essentially those were the skills that I've developed and learned and sort of got to know. So it meant then when I went on to other jobs, such as have I got it in here yet? The National Rheumatoid Arthritis Society, where I set up a service for children and young people and their families who live with arthritis. So children with rheumatoid arthritis, which often people think is an old person's disease, but it actually affects children and affects them really quite badly. But there wasn't really the help and support out there. So I set this charity up so that we could offer support just as well, emotional support, and where to get more information and be a bit of a sort of not a barrier but a communication between, say, the health service and sort of other services that were available. So again, that was looking about developing policies and developing processes. So again, as I say, in my mind, my life has just been a recipe for sort of doing things. I think the most exciting job that I had was setting up a service for the Ministry of Defence called the Advanced Study. And so Armed Services Traumatic Rehabilitation Outcome Study. And that was it's a 20-year study supporting veterans from Afghanistan and Iraq who were basically blown up on the battlefield. So you had a lot of service personnel who'd lost limbs, who'd been really severely injured. And we didn't know what their long-term outcomes would look like, but we suspected that physically they would need additional services and support, emotionally and financially because of the trauma they'd gone through, but also, difficulties in finding employment and things like that. And so that was a huge challenge because, as I say, it's a 20-year study. So I started it in 2017. It's, now 10 years old and it's still going. So that was a big challenge for me because I had to work within the framework of the MOD, and set up sort of processes and, a study that would last time. Um, so far, because of what I knew and how I knew to do things, that has been successful. But after that, I decided I wanted a bit of a change. I'd spent, 20 years in academia and decided I wanted to go and work in the NHS. So I knew about medical devices. So it was, what's out there? What can I do? How can I transfer what I know, to something else? And I found something called clinical engineering, which I hadn't been aware of, I have to say. I've been to hospital and I've seen medical devices there, but it never entered my mind. Who looks after them? Who makes sure that they're available? Who makes sure that the people using them actually know how to use them? And so that's when I discovered clinical engineering, and that's what I do now. So we look at the whole spectrum. So, somebody goes, oh, I need to buy a new, I don't know, thermometer or OBS machine or anesthetics machine. So we help them through that process of, making sure that, it's the right device, it's got all the safety certifications, it's at the right cost, we have the right training, it's right for the hospital. And so we go through all that. And of course, we maintain and service them throughout its lifetime. And when it comes to disposal, because end of life or it's broken, we can't use it anymore, We make sure it's, disposed of properly. And so again, throughout that whole process, you know, is procedures that we have to follow to make sure that these devices are safe to use, and that nobody comes to any harm. So again, as I say, I feel like my life is probably a bit grey because it's nothing but process and procedures, but I have to say I absolutely love it. So that's what I do now. And there's a couple of other jobs that you can see that I've sort of done on there. Next slide, because I'm conscious of time and I don't want to overrun, and I'm keen to get to the quizzes. So now, hopefully, as I say, these will work. I've done them with Thanvi, who's one of our interns here, and we've practiced, but obviously I don't have control of it now, so I don't know how it's going to work. So um, this is a bit of a memory game. It's just a bit of a sort of a warm up for you. And I'm hoping that you'll be able to put answers in the chat if I say to you, um, what are these sort of, well, can anyone tell me what these four symbols represent? Anybody in the chat? Are there any answers? I have to go to chat, won't I?
Yeah, just give people a few seconds to
There we
type.
go. Now I can see.
Oh, cards.
Diamond.
Oh,
Yeah,
yeah. Oh, I love
perfect.
that.
Great.
You've just been cryptic there, straight off the bat.
Brilliant. Exactly. They are playing cards. So next slide, please. I'm going to sort of do this dually so that I can do this at the same time that I've got mine in front of me. Right. So what three cards? So I have, a bit like a magician, taken a virtual pack of cards and I've selected three at random. So whoever's got control, can you click please so that three cards come up? So we've got the King of Spades, the Ten of Diamonds, and the Four of Clubs. So if you take a few seconds just to memorize those, and then Tracy, oh, thank you. Yes, can you get rid of them? So again in the chat, can you write down from memory what you think those three cards were? Ooh, let's have a look. I have to remind myself. King's King, Ten of Diamonds. Yep, we're looking good so far. So we've certainly got Gemma who's got it right. We've got
You want me to pull the rabbit out
Silky,
of the hat? Silka, yeah.
Silka, yeah, it's got it right. Bethany seems to have got it right. Excellent. So then, can we go to the next one? Because now I'm going to really test your memory. And I'm going to double the challenge.
No cheating, no screenshots, guys. No cheating.
Oh, I didn't even think about that.
No,
Sorry.
no cheating.
Right, so if you can click on, so we've got the three original of the King of Spades, Ten of Diamonds, and the Four of Clubs. So then adding to that, we've got Six of Diamonds, Three of Spades, and Queen of Hearts. So again, give you a few seconds to memorize those. Oh, they're going, and they've gone. So again, can you think about those? And in the meantime, I shall help to refresh your memory. So we had the Queen of Love, the Ten of Diamonds, three shovels, half a dozen diamonds, King of Spades, and Four of Trees. So if you can write down then what you think those were. King of Spades, Ten of Diamonds, Four of Clubs, Six of Diamonds, Ace of Spades. Oh, interesting. Mm. So far, what have we got? So we've got a bit of a mix there, haven't we? So it looks as if, though, if I can go back up again, can I go back up? Gemma seems to have got it sussed. I think, is she the only one that's got it right? Yeah, in that right order. So can we have a look at them, please? So we had King. Yep. So well done, Gemma. That is right, isn't it? Reading King of
Yeah.
Spades, Ten of Diamonds. Yep. Um, and you may think, gosh, what's all this got to do with the price of fish? Well, actually, what that's supposed to, what I'm hoping that will have shown, is that you had in your mind that there's a set sort of way of doing something, and there was a process, and there was a format of doing it, but by changing the language and changing um, the sequence, I've changed the process. And you can see by changing the process, you don't actually get, you can't reproduce what you had originally. And so by doing that, it can lead to mistakes. So that was just sort of a little way of, I suppose, introducing, procedures and processes for you. Hopefully just in a little fun way.
And I
And that
think
you're sort of like,
Silke makes a good point. You didn't say that we had to put it in the right order. So therefore was
that
Maria Benedicta's SOP or instructions or procedure, was it not
were they
clear
not
enough?
clear? Exactly. Thank you. Sorry, I didn't see that
Yeah.
comment. But this
No,
is it. And thanks for that, because that's actually a really good comment. And I shan't say too much because it might give it away for the next
yeah.
bit, but it is that you've got to be really clear about, what process you're going to follow, because you've got to be able to reproduce that so that you get the same results. And actually, if you don't, it's also really good that if you've got a process and you get different results, then you can go back to that process and work out where it may have gone wrong. So it's all really important as part of, I suppose, process. I feel like I'm saying process all the time, and I am, about the procedure, but it's the importance of following procedures to sort of avoid mistakes. And if mistakes do happen, then being able to go back and find out where you went wrong. So on to the quiz.
So just for a little bit of information, you will have no more than 15 seconds to answer each of the questions. So we're going back to Slido. It's no more than 15, and there will be a leaderboard that will show in between. So it's a bit like Kahoot, time and accuracy is taken into account as
Oh my
well.
gosh.
So I'm going to run the Slido now, and you're going to get your first question. So make sure if you haven't got it on your phone and you've lost it on your phone, you're ready to quickly scan, because you'll only have that 15 seconds to pick the answer. Okay. Are we ready? Yeah. Get it on. Look, I can see it's getting moving. There we go.
Cool. Oh, this is new for me. I'm quite enjoying this. You see, I'm one of those older people that's not quite confident with technology.
Well,
This is really good.
you provide the content, and I use it up. Right, are we ready? We're going to move on now. If you've not already signed up, get on there before we go and go.
Right, which statement best describes an SOP? Or written descriptions of regularly occurring processes, summarizes company's policy, is a one-page how-to guide for every process within an organization.
Were you quick enough? So we've had about 50% say A, 50 saying C, roughly 42 saying C, and then B, and the answer was A. So Maria, are you okay now? Are you happy to take over now that you know how it's worked for that first one?
I do, but I'm going to have to
Yeah.
do this myself.
Oh, you want to play along?
I might actually have to get Thanvi to help me to remind me of what the answers are. Right,
Yeah.
okay.
So there we go. There's our leaders. There's our top 5.
Can you tell me the answers when you... Thanks. Right, okay,
Ready?
good. Why are SOPs important? Processes can only be improved if they are written down. Achieve consistency, increase your stress levels. Option B and C. Oh, I can slow down reading, can't I?
I'll give the answer away.
Oh,
But there you go. 72%. I came up with the right one, Maria.
excellent. I wouldn't mind. I wrote these, but I've got a terrible
Been a
memory.
while since you wrote
Chaps.
them.
Well done, everyone. Good. Although I have to say that at the moment my stress levels are increased.
There we go. Our top five has changed around. Don't worry, we've still got quite a few more to go.
Yeah. What might be included in an SOP? Personal details of the Chief Executive Officer, list of your certificates or awards, description of the procedures, all of the above. Great stuff.
Yay, 90
Well
all
done.
correct.
Well done, chaps.
Oh,
Chaps is a generalisation, by the way. I call everybody chaps.
Erica's holding the lead there.
Oh, well done. Cool. What might an SOP format look like? Step-by-step instructions on how to perform routine tasks, flowcharts, checklists, or all of the above.
Hmm.
That's interesting.
Do you want to explain
Yeah.
that one just a little bit, Maria?
So I think lots of people think that SOPs have to be written down in sort of like a little booklet or a sheet or something. But sometimes you can actually have, in a flowchart, you might have something that's visual and also checklists. So you might have your document and then you'll have a checklist at the end. So all of those actually you can be used as SOPs. So it doesn't have to just only be a set of instructions. There might be other things that you can include in those SOPs. Or, as I say, you may just actually have a bit of a flow chart that, has it not only flow charts, but it's got the sort of instructions, by the side. So it's good to include all those and to sort of, think that because some people are more visual. And that might help them more easily. I do like a good list myself. So yes, it's really what works best for you.
Brilliant. Thank you. For your assessment, it is the step by step that you will be doing. I can see all your teachers going, it will be the step by step. However, when you're doing your A2 poster, for example, if you're doing like a presentation, flowcharts are much more effective visual aid for your assessment. So I could just see all the teachers going, but you're doing A for your assessment. But yes,
Sorry.
that's okay. But in the real world, it can be displayed in lots of different ways. So absolutely fabulous. Thank you. Oh,
Oh,
that's
we've got a
changed
new
things about.
leader. Okay, so what is the main reason for having SOPs? To make the manager's job easier by delegating tasks, to achieve consistency and accuracy of output, focus on profit, disregarding compliance, all of the above. Yay. Oh, sorry. I've given the answer away before it had gone green. Well
Well
done,
done.
everyone.
Brilliant. All the little shifting about again.
Oh, I do like this. This is fun. Sorry, I'm enjoying it. I hope you guys are. Which of the following is not a characteristic of an SOP? Having a clear and concise language, only accessible online, includes purpose, scope, roles and responsibilities. Option A and B. Yeah. Oh,
Yeah.
I must learn to wait. Ah, no.
No, it's wrong. It's
Who
wrong.
puts Tracy?
That's my
You're in
fault.
you're in charge. It's
90% of user right. I'm
It's
wrong.
option B because it's
Yeah.
not a characteristic of an SOP. So you see, Tracy got that wrong.
Um,
What might happen if you don't have or you don't follow SOPs? Someone suffers an injury, damage to the company's reputation, makes errors, all of the above. Let's see if Tracy's got the right one for green now.
Yay.
There, well done. Had to wait then. Yep, excellent.
Brilliant. And then we've got
Ooh,
one more to go. So last
yeah.
chance. Hopefully I've done it right and not done use a bad one. Because I feel like they would have all got 7 out of 7 otherwise. On to
Yep.
the last one.
So, what is the key benefit of having detailed SOPs? It's a reference for training new employees, it reduces operational costs, it provides a structured approach to meet legal requirements, or all of the above. Excuse me.
There we Yeah.
Ta-da! See, I
Well
wonder
done.
sometimes if my eyeballs give it away. So,
There we go. So
oh, well done.
Annalie, well done.
Well
She
done,
is our
everyone.
winner. Fabulous. Excellent.
Yeah.
Brilliant. So just for you to sort of close up and finish up there on your last slide, Maria.
Yeah. So, summary. What are SOPs and why do we need them? Hopefully, you've learned sort of, why they may be important. And just going through, excuse me, a few things here. They provide clear definition of the purpose of the work and its objectives, identification of documentation, and can identify necessary resources and tools to complete the work, something I haven't sort of gone into in depth really. Also, it's a safety precaution really, because you follow the same process that are tried and tested and known to be safe. It also means that you can review and revise them as, things change. And that you've got to use clear and easy to understand language, which I think we'd learned from, our little sort of warm up, and also consistency and, be really clear what you want. You can use flow charts as visual representations, and you could also present it in a step-by-step format. So I think that is probably the end of my presentation.
That was
Questions and
wonderful.
answers.
Thank you, Maria. Have we got any questions? Not so far, we haven't. I thought that was really fabulous. Thank you. And thank you for bringing SOPs to life for all of our
You're welcome.
students, because it
I
is
hope you
can be
enjoyed
a
it.
bit difficult one. So thank you for that. Yeah, it was brilliant. Please feel free to share questions in the background and we'll pick those up at the end. If you're still sort of going, oh, well, what about this? And we'll pick up any questions at the end. Oh, thank you, Bethany. She's giving you lots of claps there. So an
Thank you.
applause. So let's change the
Thank you. Thank
language
you.
there. So now we're going to move on to our last two speakers, which if we keep it around about the 12 minutes, Meave and Jackie, if that's okay. We've asked them to increase it a little and then we've gone, oh, we've had lots of fun with games. So we can keep that around about the 12 minutes. That would be really good. So more back on what you're originally exploring. Thank you very much. So over to me first. Thank you.
Okay, thanks, Tracy. Yeah, I'll just do a bit of a brief as to how I got into the role and a bit about my interests and skills that I've gathered along the way. So, and then Jackie will take over the second part. So next slide, please, Tracy. So before we get into it, just quick overview of what pathology is. So it's a study of diseases, their causes, processes and effects. Within pathology, it's sort of like a tree. Underneath pathology, we have different disciplines and specialisms, and that includes a whole range of staff that work together to process, analyse and diagnose patient samples. So it includes doctors, biomedical scientists like myself and Jackie, and laboratory assistant staff all coming together to look after those patient samples and get the diagnosis. So we help patients by detecting cancers, blood disorders, and providing crucial information to guide their treatment, because it's really important they get the right treatment at the right time. Next slide, please, Tracy. So who am I then? My name is Maeve Deeney, and I'm currently in a senior biomedical scientist position with a fancy title of pathology network education trainer. So my background is I started off my career in cellular pathology, which I'll talk a little bit about shortly. So that's the type of specialist lab that I chose to go into. And my base is at University Hospitals Plymouth, and my expertise the last couple of years has been on focusing on training and development of our new young people new to the profession coming up and getting them through the training so that they really thrive in their careers. Next slide, please, Tracy. So my journey into science, I always really enjoyed science at school. I loved biology class. I loved doing practical work. I loved using my hands. I didn't really enjoy the theory as such, but I liked being creative. And when I got my hands stuck into experiments, I really liked the attention to detail that came with that. I did work experience, as we all had to do in school, in a local pharmacy, and didn't enjoy it and felt really confused, had no idea where my career was going to take me or what I was going to do after school. I've attended a biomedical science open day and I fell in love with it. We walked through the labs, I saw what we could be doing all the time, and that was it for me, really. Next slide, please, Tracy. So I then chose the career of biomedical science. So I went to university purely because, again, I was confused. I didn't really know what I wanted to do. I didn't know whether I actually wanted a career in biomed. But what sealed the deal for me was I got an opportunity to do a work placement in an NHS laboratory for a year. And it was only when I did this placement and saw what day-to-day life would look like that I knew that this was the career for me. So I was given the choice, which I was quite lucky to have been given, to choose between which laboratory I wanted to spend my year in. So I had 2 days in a hematology lab, 2 in biochemistry, 2 in microbiology, and 2 in cellular pathology. And after spending a couple of days in each and finding out a little bit about each, I wasn't really a fan of blood personally. So hematology and biochemistry were not for me, as those 2 laboratories focus on working with blood and chemical components within the blood. I liked microbiology. It was working with infections and viruses and parasites and all those things. And I liked cellular pathology, which was working with, chunks of tissue essentially from patients, and seeing whether there was cancerous cells there. So between those 2, because they were so hands-on, those were my top 2, and I had to fight with another placement student, and I got cellular pathology in the end. So I really enjoyed it. That was the year that made me realize that I wanted to get into work straight away, and I was done with study. And I really preferred it, so I made sure that was what I got. Next slide, please, Tracy. So how I progressed, once I started training in my year there, I went through all the different sections in the laboratory. I started off in specimen reception, looking at all the samples coming in, checking all the details on the pots and the forms, making sure they matched up, getting the basics of a laboratory and reading all the SOPs, as we've talked about already, figuring out all the health and safety and the confidentiality, all those really, really crucial aspects of working in a pathology laboratory. And then I moved on to the bit more hands-on things, so slicing pieces of, thin tissue like skin samples, if you've ever had a mole removed or your appendix taken out or your gallbladder. So as I became more and more confident and trained up, I progressed on to more complex techniques. And then after a few more years and a bit more study and lots of training, new people coming into the laboratory, I moved into a senior role. So now I primarily focus on training and development in my trust in Plymouth, but I also help trainees across the network that I'm based in. It's the Peninsula Pathology Network, which covers Devon and Cornwall. Next slide, please, Tracy. So what I do day to day is I analyze and process tissue samples. So as I've mentioned, moles, cervical biopsies, we get large buckets of, big cancerous organs in, like colons, breasts. I'm sure we all know someone that we love that's had cancer. Primarily what we work with is cancer samples, but we do work with other things like inflammatory diseases, inflammatory bowel disease, IBS, Crohn's, things like that we see all the time as well. And we work and ensure we get the correct diagnosis for patients. So we check cells under a microscope after we've thinly sliced it, transferred it onto a slide, stained it, and then we're checking the quality of the work that we've done before a diagnosis can be made. And these are all quite complex scientific processes, and it's a little bit about those skills we talked about earlier on. You need that attention to detail, you need to remain calm under pressure, and you've got those transferable skills that you've built up over time in your career. Next slide, please, Tracy. So how we help patients then, we play a really important role in diagnosing cancer and benign diseases too, which we see a lot of, inflammatory. And we understand and know firsthand the importance of a correct diagnosis and the impact on treatment choices for patients. If we have, a 3mm breast biopsy, for instance, that can very easily be lost or disintegrated at any of the many steps in the laboratory. So extreme care has to be taken at each point to make sure that we're looking after that sample and every sample, and ensuring the quality is there at the end. So we have to be very meticulous. So our roles highlight how meticulous our work has to be to ensure that they receive the correct treatment. If anything goes wrong along the way, you have to be responsible for that and try and rectify that if possible, because at the end of the day, each sample, although we're not patient facing and we always call ourselves the behind the scenes heroes, it is really important that they get that right diagnosis and the treatment as well. And next slide, I think that might be me, Tracy. I see Jackie's typing.
Yeah, that's great. Thank you. So it's thank you for that. It was really nice whistle stop tour, really fantastic, really interesting though. You broke it down into language that I can really understand, actually what you do on a day-to-day basis. So thank you very much for that. So over to Jackie now. Thank you.
Right. I was just typing an answer to the question that's been put on there. How many SOPs does a typical biomedical scientist follow? We've got a whole lever arch file full of ones that are printed out, and I don't know how many we've got online. There's probably, I don't know, maybe 2 lever arch files full of ones that we would use all the time, and probably others that we don't use very much. But because they're all electronic, so the ones we have printed out really are the ones that are used a lot, so that people can use them with their work. But I wouldn't like to count how many there were. There's a lot, but you do get to know a lot of them off by heart. Anyway, who am I? Well, I suppose in some ways my pathway into science was similar to Maeve. I've ended up as a senior biomedical scientist and a pathology network trainer, but rather than cellular pathology, I'm based in haematology and blood transfusion. The bit Maeve says she didn't like because she doesn't like blood. I've gone through as much blood as I can possibly lay my hands on. But I think at work it is red stuff in a bag or red stuff in a bottle. You don't think of it the same as if you cut yourself. I can panic as much as the next person if someone in the room's got blood pouring out the finger, which really isn't very big and probably only needs an elastoplast on it, but it's not quite the same as when you're at work. I'm based in Torquay, which is nice because, like, at the moment I can sit out and look out the window and see the sea, and when we're in the lab we can look out the window and see Dartmoor when it's not being foggy and we can't see anything, because Torquay does that as well. Right, if we move on. Right, so I was always interested in science at school, didn't know where to go. I can remember one careers interview I had where I said I want to do something scientific-ish, and they wrote down childish. And I thought, no, it's not. I want to work in science, but I don't know what bit of science. Nobody will tell me what bits of science are out there. I did A-levels with the idea of doing pharmacy because pharmacy sounded interesting, something I'd come across. I'd been to Boots to pick up a prescription. And when it came to picking a degree, chickened out and said, no, I'll do chemistry because it's a bit wider. I can get into more things. I'm not 100% sure on what I want to do. And in my degree, I discovered I liked analytical work over research. Didn't enjoy doing my research project, but I did like it when they gave you an unknown white powder and said, right, what is it? Work it out. And then towards the end of my degree, I discovered biomedical science by chance. I was on holiday and I met someone who worked in a hospital laboratory. I asked her about what she did, which did happen to be haematology, but I didn't know what that was at the time. And it sounded interesting. So I thought, right, that's the line I think I'm going to go down. I did work experience in a crematorium. And by chance, I was speaking to one of the funeral directors who said, oh, with those A-levels, and whatever, you could go down into pathology. And little did I know at that time that basically pathology was where I was thinking of going, but I hadn't put 2 and 2 together. I didn't know what pathology was. I didn't really know what any of it was. I just knew it was a laboratory. It was in a hospital and it did analytical things. And I thought that sounded interesting. So my initial plan had been to get a job in biochemistry because it was more linked to my degree. But I wrote to lots of hospitals and one of them wrote back and said, we're actually advertising at the moment for a job in haematology. Would you be interested? And I thought, why not? Looked it up in the dictionary, thought, yep, that sounds okay. And went for the interview, got the job. Can't see why they employed me sometimes, but they did. And that was where it all started. If you move on. So once I got into my job, I mean, I did a degree in chemistry. These days you do a degree in biomedical science, but when I did mine, it was all on the job training. So now you have to do the right degree rather than the wrong degree. If you don't do a biomedical science degree, or you don't do an accredited biomedical science degree, that's the important word, accredited by the IBMS, which is our institute, the Institute of Biomedical Science, you would have to do top-ups, which can be as much as almost doing another degree. So if you are interested in biomedical science, do look at the IBMS website to see which universities are accredited. And on the whole, it's a lot of the newer universities, because that's where they used to do all the professional exams. So they had the staff that taught it and it just carried on from there. I moved on from doing professional exams into a senior role in haematology and in blood transfusion, and was a training officer for about 17 years. When I moved down to Devon, I've then got another job, another training job, which was what I'm currently doing, which is a pathology network trainer. And so I'm also an examiner. So if you go into the job and you're doing professional exams, there are some of us, and we go through and we mark them and we see whether we think you've reached a standard that's acceptable to become qualified in the career. Move on to the next slide. Right, so what do I do? Well, working in haematology, we are working with blood. So you've got a nice picture there of blood under the microscope with that cell there, which you've got all the red cells in the background, and a neutrophil with the one with the wiggly nucleus, and a lymphocyte, the one with the round nucleus. So we're looking at a lot of full blood counts, which is basically when blood like that goes through a machine. So we will do 1,500 a day, perhaps, and the machine will analyze them all. If they're normal, they go straight out. If they're abnormal, then we have to assess what the problem is. Do we need to look at it down the microscope? Do we need to phone the doctors? What's wrong with the patient? And what other tests might we need to do? So we can look for anemia, we can look for infection, we can look for clotting disorders. So someone was a haemophiliac, because we also look at coagulation, which how well your blood clots. So normally if you cut yourself, you'll bleed, you'll clot, you'll form a scab. If you're a haemophiliac, that bleeding might not stop, or might not stop very easily. So we're monitoring that. And not everything's automated. We've also got hands-on tests on the bench, like glandular fever testing, which I'm sure most people know someone who's had glandular fever. And then we've got things like abnormal hemoglobins, so sickle disease. And there are over 1,000 different hemoglobins, but it's sickle that is one of the main the significant ones medically, because it can cause sickling and you can be quite ill with it, and you may need to have lifelong blood transfusion support. And there are a lot of other tests we do. We look at, I think what else we do various hormones and things in. We share a laboratory with biochemistry, and they're looking at the plasma and the blood samples, and so they're looking for a lot of hormones and enzymes and chemicals and things like that. What happens after that? We've got the next one. Oh yeah. wasn't sure where we got to. So if you ever go to the doctor and have a blood test done, it will come to a lab like ours. So where Maeve's concentrating on bits of you that get chopped off, we're looking at bits that are just body fluids. So it might be blood, it might be urine, and we're looking at those to see what condition you might have and how doctors can make accurate treatment. So last week we had someone who came in, it was a new leukemia. They'd come into accident emergency. They were short of breath with a temperature. And when the sample was analysed, they had a very, very high white count. They were anemic. And when we looked down the microscope, all those cells were early. Now, without us, they may not have known what that was. They may have been thinking, oh, well, you've got a temperature, could be sepsis. You're short of breath, maybe you're just anemic. If it hadn't been for haematology, they wouldn't have been able to get that diagnosis as quickly to know that that patient had leukemia, and they could start treatment immediately. And that may well save their life. And I think is that the end? No? I think we've covered most of that. And then any questions anyone's got?
Let me have a look. That was really fantastic. Thank you. Really interesting just to see how you've made an impact as well. So really, really great. Thank you for that. So far, I haven't got any additional questions unless I've missed it. So thank you very much to our speakers for really sharing their experiences. Thank you for joining us on today's session. I hope that you've learned something new. You're maybe thinking about where else you might want to go now in your career choices. And I think our speakers have been really inspiring and food for thought as well, to really help support you in that decision making. So thank you very much for joining us today and your patience as we ran a little bit over. Thank you.